Zero downtime. Once the smart contract at the core of an app is deployed and on the blockchain, the network will always be able to serve clients looking to interact with the contract. Malicious actors therefore cannot launch denial of service attacks targeted towards individual dApps. Complete data integrity. Data stored on the blockchain is immutable and indisputable, thanks to the cryptographic primitives. Malicious actors cannot forge transactions or other data that has already been made public. Privacy. You don't need to provide real-world identity to deploy or interact with a dApp. Trustless computation and verifiable behavior. Smart contracts can be analyzed and are guaranteed to execute in predictable ways without the need to trust a central authority. This is not true in traditional models. For example, when we use online banking systems, we have to trust that financial institutions will not misuse our financial data, tamper with records, or get hacked. Last but not the least, what are the implications and guidelines? Maintenance of dApps. dApps can be harder to maintain because code and data published to a blockchain is harder to modify. It's hard for developers to make updates to their dApps or the underlying data stored by a dApp once they are deployed, even if bugs or security risks are identified in an old version. Performance overhead. There is a huge performance overhead and scaling is really hard. To achieve the level of security, integrity, transparency, and reliability that Ethereum aspires to, every node runs and stores every transaction. On top of this, proof of work takes time as well. A back of the envelope calculation puts the overhead at something like 1 million times that of a standard computation currently. Network congestion. At least in the current model, if one dApp is using too many computational resources, the entire network gets backed up. Currently, the network is only able to process about 10 transactions per second. If transactions are being sent in faster than this, the pool of unconfirmed transactions can quickly balloon. User experience. It may be harder to engineer user-friendly experiences. The average end user might find it too difficult to set up a tool stack necessary to interact with the blockchain in a truly secure fashion. Centralization. User-friendly and developer-friendly solutions built on top of the base layer of Ethereum might end up looking like centralized services anyways. For example, such services may store keys or other sensitive information server-side, serve a front-end using centralized server, or run important business logic on a centralized server before writing to the blockchain. This eliminates many, if not all, of the advantages of blockchain over the traditional model. And what are the development guidelines? Design. The design of the contract should be discussed ahead of time prior to writing any line of code. Documentation and specifications. Documentation can be written at different levels and should be updated while implementing the dApp. A plain English description of the system describing what the app do and any assumptions on the code base. Schema and architectural diagrams including the dApp interactions and the state machine of the system. Thorough code documentation. On-chain versus off-chain computation. Keep as much code as possible off-chain to reduce unnecessary load on blockchain network. Keep the on-chain layer small. Pre-process data with code off-chain in such a way that verification on-chain is simple. For example, if you need an ordered list, sort the list off-chain, then only check its order on-chain. Upgradability. Make a deliberate choice to support upgradability or not prior to writing any code. The decision will influence how you structure your code. General recommendations are favoring DApp migration over upgrade. Migrated systems have many of the same advantages than upgradable without their drawbacks. Use data separation method. Document the migration or upgrade procedure before the deployment. It should include the calls that initiate the new dApps, where are stored keys and how to access them, how to check the deployment, develop and test a post-deployment script or use an automation time to look at implementation guidelines. Simplicity. Strive for simplicity. Always use the simplest solution that fits your purpose. Any member of your team should be able to understand your solution. Function composition. The architecture of your code base should make your code easy to review. Avoid architectural choices that decreases the ability to reason about its correctness. Split the logic of your system either through multiple dApps or by grouping similar functions together, for example, authentication, arithmetic, etc. Write small functions with a clear purpose. This will facilitate easier review and allow the testing of individual components. Inheritance. Keep the inheritance manageable. Inheritance should be used to divide the logic. However, your project should aim to minimize the depth and width of the inheritance tree. Use available tools to check the dApps hierarchy and its size. Events. Log all crucial operations. Events will help to debug the contract during the development and monitor it after deployment. Avoid known pitfalls. What are they? Be aware of the most common security issues. They are mainly online resources to learn about common issues such as Ethernet, CTF, capture the ether, or not so smart contracts. Be aware of the warning sections. For example, the one in the Solidity. The warning sections will inform you about non-obvious behavior of the language. Dependencies. Use well-tested libraries. Importing code from a well-tested library will reduce the likelihood that you write a buggy code. Use a dependency manager. Avoid copy-pasting code. If you rely on an external source, then you must keep it up to date with the original source. Testing and verification. Write thorough unit tests. An extensive test suite is crucial to build high-quality software. For example, write Slither and Cheetah and Manticore custom checks and properties. Automated tools will help ensure your dApp is secure. Let us look at the Ethereum-specific tool Solidity. Use Solidity 0.5 over 0.4 or 0.6 as it is more stable and secure. Use a stable release to compile. Use the latest release to check for warnings. Check that your code has no reported issues with the latest compiler version. Do not use inline assembly. Assembly requires EVM expertise. Do not write EVM code if you have not mastered it. And what about deployment? Monitor your dApps. Preferably use a monitoring tool. Watch the logs and be ready to react in case of taps or wallet compromise. Add your contact info to blockchain security contacts. Add your contact info to blockchain security contacts. This list helps third parties contact you if a security flaw is discovered. Secure the wallets of privileged users. Follow best practices if you store keys in the hardware wallets. Have a response to incident plan. Consider that your dApp can be compromised. Even if your dApps are free of bugs, an attacker may take control of the dApp's owner's keys.